My pleasure to introduce our presenter. This is Kevin Postma. He's the son of members Pat and Chuck Postma. Kevin was a high school teacher for a number of years, high school science, yes.
Yep.
And then, sort of, if I understood the story right, you kind of got recruited by Gerber's and MSU to work on a project with them in their orchards, and it turned into a PhD. Well, this was during the pandemic, so, you know, people maybe had more time. I'm not sure you did because you were still teaching, but anyway, he said, sure, I'll do both, and got into that, and it ended up turning into a PhD program, which he's currently enrolled in right now. Right?
True. Yeah.
And so we were discussing his research, and I thought, oh, I bet our members would be interested in this kind of thing. And so we're really happy to have Kevin here today to tell us all about orchards and what he's discovered. And this is just one small segment of many things I think you've discovered about orchards.
This is pretty comprehensive as
yeah.
far as what I know.
Okay, all right. Well, this is good. Okay, well, take it
Although, thank you, Jane. What a nice program you all have here in Holland, Michigan. We do this, and I live in Manistee, and we have this in the summertime once a week at the Ramsdell Theater, and it's really nice. But you guys have it all year long. Like, how special is that? So. Anyways, actually, after talking to Landis, maybe we should just turn this into what's wrong with my trees. And so I don't know if I gave you any solid answers, so sorry about that, but we'll see. So we'll talk about the carbon in apple orchards. And yeah, I was a high school teacher for a long time. I got asked to be involved with this PhD research. Gerber was looking for someone to start tearing apart what's going on with carbon in orchards, and I wisely said no, absolutely not. And a week later, I said yes. I was like, this is one of the fundamental questions of our time. I have kids. I'm concerned about climate change, and you know what? Agriculture is our third biggest industry in the state of Michigan. So in photosynthesis, carbon dioxide, right? Let's explore this. So anyways, it's been quite a ride, and I present my dissertation in the spring. So you guys are getting a preview. So we'll see. I'm still flushing out data, but anyways. So with this question, we're looking at the carbon footprints of orchards. That big, ugly scientific word, net ecosystem production, what that refers to is this ecosystem acting as a carbon dioxide sink? Like, is it absorbing carbon dioxide, or is it releasing more? Is it acting as a source? So I'll refer to that, you know, that's a science word you got to learn here. And then pathways for carbon markets. Growers want to know, how can I take advantage of voluntary carbon markets? They're becoming more and more of a thing. So I can do this. Okay. So a couple of like background information things, and I'm sure most of you know, plants do photosynthesis. They take in carbon dioxide through their leaves, and they use that carbon dioxide to build their molecules like carbohydrates, proteins, and lipids. Not as many people are aware that plants also impact the carbon that gets stored in the soil. And they primarily do this actually through their roots by giving off these root exudates, which are carbohydrates that they are giving off to feed the fungi that they live in association with. And some of that carbon does end up getting locked in soil. But the thing that most people aren't aware of, and it always blew my high school students' minds, is that plants also release carbon dioxide. They go through respiration, and not in the same way you and I do, but they still need to use their carbohydrates for growing, for maintaining their processes. And when they do that, those carbohydrates get broken down and released as carbon dioxide. So like if you were to put a bag on a leaf at night, it's giving off carbon dioxide, okay? It wouldn't be till the daytime and the sun hit it that you'd see the absorption of CO2. And then also, of course, the soil microbes, as they're decomposing all of the leaves and the roots and whatever, dropped apples, they are going to be releasing carbon dioxide up into the atmosphere. So there's a lot going on in a field. And that makes it really difficult in agriculture to kind of tease out, is it behaving as a sink of carbon dioxide or is it acting as a source? And it varies throughout the year, right? If you think about a cornfield, you know, all of that green biomass out there is absorbing tons of CO2 in the summertime during the growing season. But once that stalk is dead, it's not doing photosynthesis anymore. It's going to break down and decompose, and that CO2 that it collected is going to return up into the atmosphere. Or when a cow eats the corn, the carbohydrates get broken down, and you know the cow exhales the CO2 back up in the atmosphere. So it's kind of complex. So you got to look at all the different angles. And so the Intergovernmental Panel for Climate Change, who kind of serves as like the global clearinghouse for all the data, you know, that comes in year after year, currently estimates that carbon dioxide is responsible for 13% of CO2. And then the other two big greenhouse gases, there are other ones to be aware of. The second big one is methane. In agriculture, mainly through burning of biomass and then growing of crops like rice that are in wet soils. That produces a lot of methane. And then nitrous oxide is another potent greenhouse gas, and that is associated with our use of nitrogen as a fertilizer. Okay? And then when we started doing this research and had those initial conversations with Gerber baby food, I mean, quite honestly, we were quite optimistic. Like, orchards are going to kill it compared to annual crops, because year after year they're building that woody biomass, the roots, right? They're able to store carbon dioxide year after year, and that's true that they do that. And the other thing that the advantage that orchards have going for them is in between the rows you have a grassy strip, and that is not tilled up. It is just maintained as a grassy strip, and that is able to build soil carbon. What tillage does is when you come through and plow a field, you're bringing the organic matter in contact with oxygen. And that oxygen speeds up the microbes, the bacteria, and it allows them to do their stuff faster, and they're able to decompose organic matter quicker. So, and why do we care about having carbon in our soils is because that acts as a storage capacity for the soil. It's kind of like your refrigerator, right? Before we had refrigerators, food went bad very quickly, right? The power went out, your well didn't work, you couldn't get water, right? Now you have your refrigerator acts as a reserve. And if we're able to store carbon in soils, it hangs on to nutrients better and it hangs on to water longer. So, I'm not used to having this fancy clicker. So my research. My first objective is I'm looking at the carbon footprint of farming practices. And I'm looking at this, I don't know if you've driven around, have you noticed that we're now planting apple trees like grapes, like on these trellises? Yeah. So as we do that, how is that impacting our carbon footprint? My second thing, here's that big ugly word, net ecosystem production, NEP. Are our orchards acting as a sink? Are they absorbing CO2 or are they releasing? So, number three, well, it takes some really expensive equipment. I'll show you that in a minute. But number three, can we pretty much estimate that without using that expensive equipment? You know, make models to do that. And then number four, looking for one particular pathway to maybe make carbon credits available for growers. So, and this is an experiment using deep-rooted grasses in the orchard alleyways instead of the long grasses that are used. We'll get into all those. Okay, so let's talk about the first thing, which is the carbon footprint. And so what a carbon footprint is it's an estimate of the amount of emissions that it takes to produce something. So in the case, you know, in science, we like to use kilograms, right? So how much carbon dioxide is given off to make 2.2 pounds of apples. Okay. So what we used for this is Michigan State, like every 5 years or so gets together with Michigan State Extension. They sit down with growers and they sit down with people in the apple industry and they put together a cost of production. And that cost of production says, okay, if we're going to put in a block of apples, what's that going to cost? And they sit down and they what are the machines used? How much labor? How much fertilizer? How much? And it's just a wealth of all this information. And the reason they do this is when a grower wants to put in a block of apples, they need money. They're going to have to go to a bank, or they're going to have to go to somebody, right? And they're going to have to say, okay, I need to borrow this much money. Here's my justification. And here's how quickly I'm going to get payback on that investment, right? So I mined it for the global warming impact things. And what I did it from the cradle, from the year 0 when the apple orchard is going in, up until year 24. And that's a kind of a good approximate age, but I mean, apple trees can live to 100 years old too, or probably even older. But people get tired of varieties. And how many of you love Red Delicious? What? One person. Honeycrisp? Yeah, there you go, right? So, there's the proof. So this was our source of information. And I'm learning how to use this. There, don't you love it, numbers? Sorry. But my high school students just love numbers. So here's what you got to pay attention to. So this bottom thing right here is the carbon footprint. Again, how many kilograms of emissions per amount of apple that's produced? And let's look at this low density. This is your traditional apple orchard. When you think of in your head what an apple orchard is like, you have a self-supporting tree. It's not on a fence, trellis. 136 trees per acre, right? Nice space between them. And we see that it has 0.0, we'll say 5 kilograms of carbon dioxide emissions per apple. And as we move towards those higher density orchards, these have as many as 1,200 trees per acre. I have all my numbers are up there in hectares, sorry. I wish we just had either English or metric, and it's sorry, but we'll talk in acres. That's what you and I know, right? So anyways, as we move up in these higher densities, you see that the actual carbon footprint drops, okay? And why is that? Because some of the things are actually worse with this. If you look at fertilizer emissions, and you see that as we move to the right, it takes more fertilizer to grow more trees, right? And these fertilizers have nitrous oxide. They have those greenhouse gases emissions associated with them. And there's a whole lot of varieties out here, like what type of soil is this and that's why there's a little bit of a band down here. And there's nitrogen inhibitors. With Landis, I was just saying, hey, you might want to use the type of fertilizer that they call it slow release, like Osmate is it hangs onto its nitrogen a little bit longer and keeps it in the soil instead of releasing. But it's a little bit more expensive. But so some of these things go up, but as you look at like crop production, actually, these higher efficiency orchards were more efficient at applying pesticides like insecticides and fungicides. That's a little bit better, but the big thing is you just get way more fruit per amount of output of emissions. So we're just a lot more efficient with them, right? So these newer orchards, growers are moving towards them because they produce more fruit, but there's a climate benefit towards moving towards that more intensive agriculture too. Okay. So that's our takeaway, that these higher density orchards have a lower carbon footprint. And I'm really proud of this. This just came out a couple of months ago. It is the 2025 cost of production estimate for apples. And it's the first time, to my knowledge, that any state has attached greenhouse gas emissions to that cost of production. So it's kind of exciting. So at least I think so. Okay. And then the second part is, how do we quantify the net ecosystem production? How much carbon is either coming into this ecosystem or being released? And so this is actually looking down from my tower. I'll show you my towers in a minute. But this is in a moderate density orchard. It's not one of the highest, but it has 778 trees per acre. And you can see the fences, right? And then this is looking down at, looking in the rows of the low density traditional orchard. So 136 trees per acre. What's your hypothesis? What do you think is going to suck in more CO2? A lot of trees or less? Okay, it makes sense, right? Yeah, that's what I thought too. Okay, so how the heck do you measure this? There is, believe it or not, there is a way to directly measure this, and it's not voodoo. So when the wind blows across any ecosystem, because of friction with the ground, it causes the wind to roll like a ball. And so it sets up these eddies, and these eddies are circular pockets of air, right? And when the eddy comes down, it's going to bring air from the upper atmosphere to the orchard. And when it goes back up, it's going to bring the air from the orchard back up to the atmosphere. So you have this mixing zone. And so if we can set, well, if we can set a carbon dioxide probe right up here, and let's say the eddy is carrying 6 molecules of carbon dioxide when it comes down, and when it comes back up, it's carrying 4 molecules. 2 got picked up by the orchard, right? And so photosynthesis grabbed onto those. And if you leave it out, these are collecting data 10 times a second. So, and I keep them, they're in the orchards for several years because conditions change, right? You have droughts, you have, whatever, high apple production years, low apple production years. You can get a pretty good sense, though, of what's going on in these orchards. So this is my tower in the low density orchard, and this is kind of looking up, I was fixing it. And by the way, this is the CO2 probe, but it's paired with an anemometer, and the anemometers measure wind speed. And in this case, what we care about is how fast is the air coming down and how fast is it coming up. Because the computer, I don't do this, the computer is able to track when those eddies, it can tell when the eddy is coming down and back up. So your hypothesis, high density, low density. So our low density orchard, and this is my first year I had both of the orchards up so I could compare them, to each other, apples to apples. No pun intended. But so low density, 421 grams of carbon per meter squared. So meter by meter. That's supposed to be meters. I don't know. I screwed up my, not a negative meter. But anyways, in the moderate density, 439. That is not a big difference. I mean, that's within the air of the machine, right? So we can essentially say, okay, both of these orchards are pulling in the same amount. So what the heck is going on there? Well, in talking to a tree physiologist who I've been able to work with at Cornell, he's like, yeah, it doesn't matter how many trees you have out there. It's the canopy. If you have 778 trees out there, they have tiny little canopies. And if you had one ginormous tree out there and it had the same amount of leaves, it's the light that's being intercepted. That's what matters. And so we measure the light interception. Our low density orchard intercepted 56% of the light. and the moderate density about the same. So it's not surprising that they're the same, but not the end of the story, right? Because while we're interested in how much carbon, the NEP that those orchards pull in, we can't count all of that carbon because, ma'am Kit, when you eat your apple, you don't have to right now, but when you eat that, you're going to take those carbohydrates, you're going to break them down and exhale the CO2 out your mouth. That apple got picked 2 days ago, and I'm assuming you're going to eat it this afternoon. And I don't know, 2 weeks of carbon storage, like that's not enough to get us out of the problems with climate change, right? So, I mean, yeah. So we have to subtract that. We can't count the carbon that's in there. So go to grower bushel records, right, and subtract those amounts. Do you notice how much more carbon is in the moderate density orchard? That's quite a bit. Now, there are some weird things going on there. 2024. In 2022, we had a amazing record-setting year for apple production in Michigan. And then we had the same thing again in 2023. And 2024 wasn't bad either. But they ran out of places to put apples. And so they have these cold storage places to keep and store apples, processing places. In 2023, these low density orchards have some varieties that they use them for processing, but they're not Honeycrisp, they're not Evercrisp, they're not Cosmic Crisp. They're not the ones that people want. And so they had to leave a lot of this out in the orchard. So that's why the amount came out of there was pretty low that year. So, and then obviously we've talked about farming emissions. We got to subtract those. But when we look at our orchards as a total, we can see that our low density orchard is acting as a carbon sink. Our moderate density is acting as a carbon source, but 29 grams, a gram is like a tiny paperclip. Like they're pretty much both acting, they're right on the edge of carbon neutrality, which for agriculture to include this, and they're still bouncing by carbon neutral is actually pretty good. When you look at annual crops, it's hard to even get it's hard to get this data out of those reports. Because I don't know, maybe they don't like to report them because it doesn't paint a very good picture for annual cropping. So, I don't mean to call carbon neutral. I actually think it's a pretty good place for orchards to be. So, takeaway from that chapter of my dissertation, they're roughly carbon neutral. Higher density orchards are able to put a little bit more of their carbon into fruit, and those lower density orchards are putting more carbon into the wood, which is why growers are switching to higher density, right? The wood is just a waste product in the end for them. Their goal is to grow apples. They'd grow them on bean stalks if they could, right? I mean, they don't care. So, okay. So then, real quick, $140,000 combined. That was the sticker price for these contraptions. So thank you, Gerber Baby Food. And that doesn't include all my hours driving out there or probes that get broken and what have you. So yes. This?
Low density versus. Your chart showed low density versus moderate density, but you didn't compare high density.
Yes, I don't have a tower in a high density orchard. So I was looking that it would be great. That would be the ideal. The problem is I was looking to install in very similar ages of orchards. And so looking at the ages of these trees and these trees, I think these are like 20 and these were like 18 years old. So trying to kind of compare that within the same parameters. And 18 years ago, this was the high density that was being planted. Today, like I showed that picture earlier, today they're going in at even higher densities. So that's a good question. Yeah.
I know you're talking about apples, but is the same kind of research going on for like cherries and peaches? I mean,
To my knowledge, no on cherries. There's been some on peaches, a lot on almonds, because of California, like a lot on almonds, some on avocados, and of course oranges have gotten some attention. So yeah, the problem there, a lot of this research happens in annual crops, because we grow a lot of them. But all of these things are specialty crops, and which is great because it makes little niches for people like me to kind of hop in and steal what they've already figured out and try and apply it. Okay. So, okay, those systems, they're way too expensive, right? To put in every orchard, right? You'd be spending more on the science than you would on getting apples. Apples don't make that much money. So, what do we do? What do we do next? So, we were looking for ways to come up with accurate estimates. And there's an app that most apple growers have on their phone. It's called MaluSim. And in the springtime, apple growers, what MaluSim does is it tells an apple grower what is the carbohydrate balance that's inside the tree. Because if a tree has like a week of just ugly rainy weather, it doesn't have photosynthesis, so it's going to be using up its carbohydrate reserves, and that means it can't support as many apples going forward into the summertime. And so the tree ends up self-pruning. It drops those apples. It knows it can't support them. But then, like the basket apples that I have out there, they're small. Like this isn't going to earn a premium price. In fact, this orchard was not even harvested, which is why I was allowed to take the apples. So the apples didn't cost me anything. So, they're just too small. So they would want to apply a thinner, and you want to kind of target how much thinner you need to apply. So that's what this app does. And
Kevin,
yes,
apply a thinner like they kill the trees, or they try to
I'm
not
sorry.
have another fruit?
a
or-
fruit thinner. Yes,
Okay.
yes. It basically forces the tree to drop some of its apples. It gives the tree a little bit of stress. And the Alan Lasco from Cornell who developed this, I got in contact with him and we talked and talked and talked, and it's like, okay, let's extend this model out for the entire year and see what it tells us and see how it compares to our results from the eddy covariance towers. And it's really cool because it ties into Michigan has these weather stations, enviro weather stations. They're all over the state. And so you tie into super local weather. It grabs how much sunshine, it grabs what the temperatures are. It doesn't grab soil moisture. So it does make the assumption that the trees are not under water stress. They're not being hit by, it's a model. It's taking a best guess, okay? And we thought that it would work well because there's a team in Italy that's done a lot of work in apple orchards, and they found out that in terms of photosynthesis uptake, trees do 90% of what the orchard is doing. So if it's 90% trees and 10% grasses, let's just say that's good enough and use this MaluSim app and go from there. So when we ran it, the results are really good. So our R square values, like this kind of like if one goes up, does the other one go up? 0.71 in biology is really good. So the app works well. The app overestimates what's going on. So if MaluSim says we have 4, and then we go up and we trace it over, the actual measurement was only 3. So it's overestimating, but that we expected because it's just looking at the tree, and you have all this soil that's giving off, it's decomposing things, and that CO2 that's given off is going to override that. So that kind of met our expectations. So that's great. By the way, I had to look at the difference between the 2 orchards. So low density is blue and moderate. Like, I mean, they're a little different here. On May, same dot. So that whole tree density, you can really see that it actually doesn't matter in terms of amount of carbon dioxide that's taken up. I think that's amazing. And by the way, this was 2024 when we had data from both orchards. So that was a great year. Last summer we had great rainfall. We didn't have the drought that we're having this summer, right? In Holland, you guys have been pretty dry. Manistee, it's been like crazy wet, and I know, like we're not that far apart, but anyways, so it fits really nice, and you see these big old jagged, like, okay, so 0 would be no photosynthesis. This is like nothing's being released, nothing's being taken up. So you know, like on a frozen winter day, you'd expect it to be right here, okay? And then when these peaks go down, those tend to indicate decomposition. We probably had a nice rainy period here where it's warm and wet. Things decompose really quickly. You know, big jagged spikes going up. We had some really nice sunny weather. So 2024, I said it worked beautifully. 2023, it fell apart. We had a drought in the springtime, which created this nice sunny weather, which the reality way overshot the model. And then we ran out of soil moisture, and the trees basically dropped. They didn't drop down to 0, but they struggled, right? They didn't have the nice peaks. So our model failed when it comes to drought conditions. So it's going to be interesting this year, because if kind of looking back, I think we were pretty good on rainfall going into maybe like July, and then by August is when it really, or did it start getting even dry in July here? Yeah. Okay. 30 days. Good luck gardening. Yeah, no kidding. We had so much. Oh well. So I guess our takeaway is when the conditions are right, MaluSim does a great job. The benefit is kind of moving forward, there are very few growers who are putting in, if you're going to spend $200,000 putting in a block of orchards, why would you not spend an extra, I don't know what irrigation costs, you know, we'll say 25,000, I don't know. Why not spend that extra amount and put in that safety? So MaluSim would estimate well in irrigated orchards, but the ones I'm testing did not have irrigation. Okay, so that gets us through part 3. Now the question, you know, how do we use orchards to combat climate change? What can we do? Are there any options for growers to participate with these voluntary carbon markets? So if they do, there are some guidelines that control the voluntary carbon markets. And these are established by the Intergovernmental Panel for Climate Change. And the sequestered carbon to participate in these has to be additional. It can't be business as usual. And, you know, apple farmers are growing apples. They're not trying to grow wood, right? They grow it on beanstalks if they could. So even though they're producing this wood, which is storing carbon, because it was grown during business as usual, they can't claim it. And unfortunately, the results kind of bear out that, you know, all this carbon that's being sucked into the wood, it basically is enough to negate the emissions that are given off, and we lost the apples, they left the orchard, right? So we got a couple questions. So what can we do? One idea I had was utilizing the orchard alley to use those grasses. Can we do something different there? So I'm going to share my results, at least what I have so far. A couple of other ideas focus on, and my research hasn't focused on it, but I read a lot about it, is how can we better utilize the woody biomass at the end of the orchard? Because right now, what do growers do? They bulldoze the apple trees into a pile, light it on fire, and all that carbon dioxide that has gotten absorbed gets re-released to the atmosphere. So, you know, it really kind of cancels itself out. And even if that orchard made it 50 years, we still need to lock away carbon more, right? So biochar is one that I am personally super excited about. Another one would be like combustion. They're talking about turning the coal plant in Manistee into a biomass plant that's going to burn and then capture carbon, stick it into old oil wells. And actually burying wood is another idea. Yeah, Jane.
So I just had a couple
Yeah.
questions about these intergovernmental panel for climate change.
Yep.
Does that still exist here in the United States right now? I mean, just a question. I mean,
So yes, the
just-
Trump administration is not sending anyone there.
okay.
I am a member of the AGU, American Geophysical Union. And we are sending people that are the climate scientists. The AGU is sending them, and they're acting on behalf of the United States in terms of, you know,
So kind of informally acting.
Yeah.
Okay. And then
it operates through the United Nations.
okay. Okay.
So-
Good. That's helpful. And then the guidelines for voluntary carbon markets. I mean, so they don't have to do this, but they can. But do they get some kind of recognition for participating in this, or is there a monetary gain to them for being in
Yeah.
carbon markets?
Yes. So biochar is kind of a big one right now. And I'm kind of talking off the cuff. This isn't my area of expertise. But Microsoft just did a huge purchase of biochar. And how a voluntary market, and you know, and this is a whole, we could spend hours and months talking about the pros and cons and everything. But the idea is Gerber seeks to go carbon neutral. And they made a commitment like by 2035. There are going to be some things that they cannot eliminate. Like you can switch your energy sources, move them towards renewable, right? But let's say trucking, transport, like we're just not there with electric trucks currently, right? So could you buy carbon credits for someone that is doing something additional to offset the pollution that you're doing? So that's how they work. But there's no like mandated. Companies do this because they've made that commitment and want to. So good question. And you know, okay. Oh, what is I'll get there. I'll get there. Yes, same thing. Okay, we'll get there. We'll get there because I love it. And even though my research doesn't, I'll give you the little speech. So my research though was taking these grass alleyways, and can we do something different with them? Can we utilize the plants to kind of drive soil carbon, what's planted there? Currently, what you have on your lawn is basically what's used in orchards. Kentucky bluegrass, creeping red fescue, right? They're cool season grasses. They're not particularly deep rooted, but they're really good at what they do, right? They establish themselves quickly. But can we do something different? So we went in and rounduped and disked this in existing orchards and in my main research orchard. We also did it in a commercial orchard up in Bear Lake. And we replaced it with these deep-rooted grass mixes, right? It kind of looks like it needs a haircut or something, right? Okay, so here's the working idea on this. Dr. Kravchenko's lab at Michigan State in 2018 came out with a paper that more or less kind of figured out the mechanism behind how soil is able to store carbon. For a long time, the going idea was, like, if you just plant a crop that has a lot of biomass, have people heard of switchgrass? It's like a prairie plant, and like, but it didn't work. Like, if you went out and just planted a monoculture of switchgrass, what ends up happening is the roots grow, they die, they grow, they die, and they just keep using the same soil pores. They don't do anything new. In Dr. Kravchenko's lab, they figured out that it has to do with plant diversity, because when you get a whole bunch of species that are competing, the roots are just a tangled mess, and you have all these different roots that are competing for nutrients and moisture. And that's what creates these really tiny little micropores from 30 to 150 nanometers. And it's in these really tiny little pores that bacteria, when they're chowing away and they're eating things, the bacteria poop gets associated with clay particles, and it gets trapped there instead of being exposed to oxygen, where it would get turned into carbon dioxide. Because in these tiny little soil pores, it's hard for oxygen to kind of make it down those tight little channels, right? So that's kind of the key. And would plant diversity increase this? So we sat down and it's like, okay, let's try and put together some plants, some grasses that we think could survive in an orchard, because orchards are not like native grass planting, because they have these tractors that are going through there, 14 times a season, getting all compressed. And they also have to deal with the shade on both sides, right? So we consulted Bill Schneider, a wild type nursery over by Lansing, and Esther Dernwall, a Michigan wildflower farm by Ionia, and tried to, they're experts. They know a lot more than I do. And I would research and throw it to them, and we kind of go back and forth. So we put together 3 mixtures, a short one, and the intention there is we're going to put together a grass mixture. Growers aren't even going to have to mow. The second one, a little higher, about a foot, foot and a half, and then a tall stature. These are like the wild prairie grasses, when they're tall as me, and, let's see how they do. So here are the species, and, the blue means they're cool season grasses. They do their thing in the spring and the fall, and the red ones they do their things in the middle of the summer. Do you notice in the short stature, it's got some weeds in there? Remember that. Medium stature, kind of looks weedy too, right? Yeah. And then that tall one, the tall stature mix it's done a nice job. So we've upped the diversity, not a ton, but we've got warm season and cool season, some deeper rooted. All of these are native grasses. And this is how they did. So we planted this in 2021, and then the next year I went out and did plant coverages. And so what do you need to know? From here on up, these were intended. These were weeds. And so about 50% of what we intended was there after a year. And we had 50% weeds. And then as we move forward through time, what was intended did better, and it suppressed the weeds. So that is in our control, the normal lawn grasses. Remember what I said about remembering weeds? My short stature mix, this much is weeds. That much. This is after year 1. Now, as we move into 2025, these are the grasses. So they're competing better. And there were some nice surprises, a plains oval sedge. no one's really used sedges before and things like this. So it was kind of nice to see that some of the species were holding their own. Medium stature, same thing. This much was weeds, after 1 year, but it shrank down to there. Not too bad. And then our tall stature, this much was weeds the first year. But then some of these, like big blue stem, little blue stem, all of these are some of the other varieties. Like they're doing their thing, right? It's holding its own. And in fact, try to give a comparison. So what we planted, again, here are years at the bottom. And planted is what's intended, and then volunteer is a nice way of calling weeds, right? So you can kind of see, I think what we plant on our lawns, there's a reason we probably settled on some of those species, right? They establish themselves pretty quickly, and they dominate, right? They kind of elbow out the weeds. Your native prairie plants. Has anyone ever done native plants? No. If you get into native plantings, they take a while to establish themselves. Manistee High School, we planted 3 acres behind the high school. So the first year, the second year, you're fielding questions from the school board like, why does this look this bad? And but it takes time, right? They take time. But honestly, to be self-critical of this, my hope was to introduce something, new and novel, and maybe this will be something to change. That's a hard sell when it takes something that many years to establish, right? It just is. Okay, diversity. This kind of gets into the whole diversity is what creates those soil pore channels, and this is using the effective species. Like if you went out, like essentially how many species are out there, and you can see the tallgrass plot does have more species. So we've achieved that diversity. Here's our control. And then, of course, we want to know, what is this doing to soil carbon? Is it having an impact? Now, I drove here from Michigan State this morning. I was in the lab till 8:30 last night running soil tests, not to get them ready for you guys because I knew I want to get there that quick. But we're still running 2025 soil tests. But soil carbon takes forever to build. And I'm trying to do my PhD in 5 years. And really, you should be looking at 10 to 20 years with soil carbon. It's just slow. So what we use in place of that is soil microbial biomass, which is the amount of carbon that is in the bacteria and fungi of your soil. And that is an indicator as to the direction that carbon is going. So kind of, which way is the wind going, right? So we did this 2 years ago in 2023, just kind of we did our top 2 layers of soil, top 10 centimeters, like 5 inches or so. And 2021, all kind of the same, but it does look like our tall grass, those big burly grasses do seem to be doing it. And these are not statistical differences. This is just pointing out a trend here. We go down to, whoops. Sorry, I have it 10 to 20, but I have it mislabeled up here. As we go down to 10 to 20, you see that our tall grass mix is doing it. Is probably building more soil carbon. And then the other interesting thing too is I'm in the entomology department, but I deal with soil carbon. So I'm sort of like the ugly duckling, and what I research has to do with nothing what everyone else is doing. So, but nematodes are these little round worms that live in the soil, and you can take a teaspoon of soil And you can find all of the different feeding groups that you would find in like, you know, the African safari, right? You're gonna find your herbivores there, you're gonna find your predators, the omnivores that eat everything, bacteria feeders, fungal feeders. Right here is a plant parasitic nematode. And you can see it's got like a little dagger that she uses to punch into tree root cells, and then she'll use it, you know, suck it out. Here's a predator nematode. Can you see? See if I can learn how to use this thing. Oh, there you go. See the little teeth right up there? It's kind of cool. Like I took these pictures. Sometimes you'll be looking at it and you'll see one of these predator nematodes has another nematode in its mouth and it's just sucking it in alive. It's pretty amazing. These fungivores, oh, they have like a little stylus like that one, but it's smaller. They feed on funguses. And then this is a bacteria feeder. You really look at their mouths to kind of figure them out and just kind of classify them down to their feeding habit. But you can tell this, and then they have like a little gizzard type structure there. So it's kind of interesting that the plant community as a whole impacts this microscopic animal community. And this nematode channel ratio, okay, what it means, here's 2023, 2024, and 2025. And if we are above 0.5 to 1, we have a bacteria-dominated community. But if we get below this, we have a fungus-dominated community. So you're looking at, you do a little mathematical thing with a number of bacteria feeders and fungal feeders. But as we move through time, we see the plant community is changing the animal community to be more of a fungal-dominated community. And these are in all of these crops. There was no statistical difference in this. You know, but it's interesting just to point out that plants change ecosystems, right? They're the ones that drive it. They capture the sunlight. But the thing I was really curious to see is that in other studies, when they've looked at plant diversity, you end up getting the herbivores better controlled by the predators. So, which makes sense, right? In the Amazon, you have like all kinds of good control of your herbivores by your predators, by your jaguars, right? One of the problems we have in Michigan is we don't have good control of our deer population, right? So, see, you know, we're thinking at a super microscopic scale. So, as we go down and we move through time, in our tall stature mix, these are the plant parasitic herbivores. It's not statistically different, but you can see the trend. And then when you look at the predators, it's not statistically different, but you see the trend there. There's a lot more predators in that tall grass mix. And then this is a ratio of the predators. Sorry, I'm getting mathy on you. But you can see that the ratio of predators to the plant parasitic ones, they're keeping that growth of the plant parasitics more in check. And plant parasitic nematodes are a problem in apple orchards. They feed on the roots, and they also tend to transmit viruses from tree to tree. And you can imagine in these super high density orchards, that's very easy to get that transferred from one tree to the next. So, you know, it's interesting to see that this level of control in the nematode community that has been talked about is actually happening in this orchard. So, of course, you don't want to solve one problem and create other problems, right? You're planting these big burly grasses. Are they going to interfere with our trees? That's a good question, and what we've tried to grab onto. So we measured like the trees, they're bordered on both sides. Is there a difference in their trunk cross-sectional area in that yearly growth, annual branch length? no statistical differences. And then growers are super concerned with metal These are these, yep, just a second, Dad. Let me finish my thought. And then they're these like Chewbacca looking mice that they chew on the roots. And so in this spring, as soon as the snow melts, that's when you can see the little meadow trails. And so we went out there and there's no statistical difference. The meadow voles use all of the treatments. Yes, ma'am.
I was just wondering did you ever control for the type of pesticides that are used on these various crops?
Great
I
question.
just wondered because I go down to Indiana, my family lives by this huge apple orchard in many acres. And 2 or 3 times a month, a cloud of white comes over
Yes.
that place. You cannot breathe. They have to notify my cousins about when they're going to do this. I think that I would like to see if there's any control for those variables.
Yeah. In this, all of the trees were all of the treatments were treated the same. In fact, honestly, like in my first row, I have one replication, another replication, another replication. And they're just in the same row. And then you go over here and they're all mixed up. So exact same amount of pesticide sprayed everywhere. There are a lot. In collecting some of the data, I know when you go out and plant corn or soybeans, there tends to be maybe later in the year, 1 or 2 more passes where a tractor has to go out and apply things. In an apple orchard, the average is 14 passes with a tractor to get the apples. So a lot of pesticides, yes.
Well, and the other question that made me wonder is, do they treat for these infectious or these destructive nematodes?
They
I mean, is
do,
that part
yeah.
of the parasitic, control or something?
Honestly, when they do it is at the beginning of an orchard. It's most harmful to trees when they're being planted. And what ends up happening, they call it the apple tree pest complex. And the nematodes carry it from tree to tree. There's some funguses that are involved too, and it's a whole nasty mix. A lot of times what they do is they actually fumigate the soil. And it's, what is it? Something bromide. Yeah, it's nasty. You're essentially killing all life down to a certain depth. There's a fair amount of research going into it. Most growers tend to use the fumigation, but mustard, there's a mustard that applications of the mustard, and I'm talking off the top of my head, this isn't my area expertise, but are almost as equivalent. You get really good effects. And also sometimes planting the year prior to planting with apple trees, planting with wheat, for some reason has really good impact on controlling these nematodes. So.
But it looked like in your research there, and that's why I wondered, so it sounds like they tried to kill them all off, but there was some impact of these taller grasses on reducing the more destructive nematodes, the root sucking nematodes,
Yes.
whatever you called it.
Yeah, they
So-
keep, and you can even see, like, as these grass treatments establish, our plant parasitic ones are going up, our herbivores are going up, and which makes sense. Like, as you get more plants, you're going to have more plant eating things established. It's just they were kept in check a little bit better by the predators. So. Good questions. I'm almost done. Hang with me a little bit more. You guys asked about biochar. Bottom line on my research, the results still aren't in. I don't think it's going to end up being a practice that's adopted. It's a lot to take on. The grasses are slow to establish. I hate to be pessimist about my own research, but it is what it is, right? You do experiments so that other people, and then you try and publish it so other people don't say, hey, I wonder if, right? And so I mean, that's the part I'm really excited about, the carbon footprints and the NEP, but yeah. So here, the one that really intrigues me is biochar. And the awesome thing about biochar, well, here, let me give the details. So you've got these, let's just say if you're gonna take your trees and you're gonna burn them up, let's just say carbon in, carbon out, let's just say that's 0, right? So right here, I just said negligible. For an open burn, you don't get that. But there are other greenhouse gases. When you're burning things, you're going to release methane, that's CH4. And the protein containing molecules that have nitrogen are going to give off nitrous oxide. Combine those together. This is these other greenhouse gases that are given off. So in California and Oregon, because they also have problems with fires and they're breathing in enough smoke already, they're trying to incentivize orchards to do something else. So they do a lot of grinding and mulching, but like mulching, like you got to replace your mulch every couple of years or every year, right? It decomposes, it goes up in the atmosphere. So let's just say the CO2 is negligible there. We don't have methane, we just have nitrous oxide emissions from nitrogen containing molecules with that method. Biochar, I'm going to show you how it's made. So you do have some burning to get it going. It's pretty comparable in terms of that, but you end up getting, what is this? 32,000 kilograms of CO2. And this is based on an orchard that is 24 years old, like, on a hypothetical model, like how much wood would develop. So you would save about 30% of that carbon, keeping it in the land. Now, biochar, one of the things that's great about biochar is it's durable. It doesn't decompose very readily. And when I say readily, if you had a kilogram of that biochar and you threw it on the ground and you came back 100 years later, 89% of it is expected to still be there. So it sticks around. Bacteria have difficulty breaking it down. How do you make it? You're burning wood except without oxygen. So I'm showing you, this is like an artisanal method. People who want to do this kind of on a small scale utilize these. There's a guy up in Benzie County that does it. And you get the fire going at the top. So this is about 3 feet tall, maybe about 8 foot in diameter. And you keep the fire up there, and then as the things burn, they fall into the pit and they continue to cook, but there's no oxygen, so they just char. Okay, so biochar, it's very similar to the making of charcoal, but it's done. I think the technical difference is this gets less oxygen. Utilizing this method conservatively retains about 30%. There are better methods of making it more industrial that could get about 50%. But you can, while we're saving the carbon, this actually can be used as a commodity and it can improve the orchard. A lot of times we use that term resiliency. What do we mean by that? Well, it starts to get dry, it hangs on to some water in the soil. Or we get a lot of rainfall now, and in our sandy soils that washes those nutrients away. Biochar hangs on to those. How does it do it? Biochar has a very porous structure. So these are carbon rings. It has a very weak electrical charge, so it's able to hang on to anions and cations, like calcium has a +2 charge, so that it hangs on to that negativity. So it does a great job of hanging on to nutrients in such a way with that roots are able to pull those nutrients off of the biochar because it's a weak static electrical charge. It's very porous, so it hangs on to water well. And it also provides habitat for microbes. And in agriculture, just like our bodies, we're realizing that you want to take care of that microbiome, right? That you have in your guts. we're realizing that this has a lot of benefits for us too. So they in meta studies, the research of biochar doesn't date back more than 20 years. And you know, a lot of initial biochar studies were just dumping a ton out in a field and hey, does it have an impact? And we're finally getting to the point where we're starting to kind of tease it out for this crop. How much do we want to apply? What type of biochar? Like what it is. But for kind of all crops combined, we're talking 10 to 17% increases in productivity. That's good, but it's not as good as fertilizer, right? So yeah. And it actually acts as more like a carrier for the fertilizer. So you actually don't want to apply biochar just straight raw because it's so absorptive, it can draw nutrients out of your soil. So it's the sort of thing, if you start playing with it at home, oh my God, my garden this year is just killing it. Of course, I got rain and you didn't. But I had biochar and it sat with chicken manure and kitchen compost like all winter. And man, that's like, it's like 96% sand where I am at. And I have the worst garden year after year. I'm proud of it. But anyways, so there was a study that came out of China last year. And again, they're trying to tie in like how much per tree. And at an application rate of 13.2 pounds, so that's about a cubic foot of biochar, they actually saw a doubling of yields in 20-year-old apple trees. And then when they looked at parameters like the diameter of the fruit and the bricks count, a lot of the qualities improved. So I'm really excited because I think this is a win-win. You get the benefit of locking away this carbon long-term, 89% over 100 years. That gets us to the point where we need to be talking about solving climate change for our children, right? Carbon dioxide has a long-term residency. So
I have a
yes,
question.
and
there's
this
a
is my
question.
final slide.
Oh, okay. Well, good timing then. So
Yeah.
you said you have to judiciously apply this biochar. I mean, like, do you I don't know, sprinkle it on the soil and then work it in, or what are you talking about there? I don't.
Yeah, you really want it where the roots are. So in my garden, in my compost pile, I essentially put it at the bottom, made my compost on top of it. So, you know, the rainwater is going to be leaching it down there. And then when I applied it in the spring, I just went and kind of rototilled it so it'd get in with the roots.
A farmer would have to do something similar around his trees. And would it just be like once, or do you do it every year since it lasts for eons?
Yeah, you can actually do it once. And so we are doing, not this week, but the next week, we're a grower in northern Manistee County. He pulled out an orchard last year. So he's got all these trees and big piles of them. They've been sitting out in the sun so we can do this. And we're going to convert it into biochar. And then he is going to be planting his new orchard, and he'll be mixing in like a certain amount. Whenever he puts in a tree, that'll go in the hole. And yeah, so.
Kevin, did you already mention that the biochar for us city folks would be available commercially?
You know, it's okay. No, and I'm tossing around the idea when I'm done with my PhD, actually jumping in and trying to start a business with it, because it's one of these things that there's a ton of research, and I go to the conferences and it's biochar this and it's biochar that. And you know, people get excited about things and then it comes to pass and the research doesn't prove it effective. And this, I get enthused because I'm looking at the results. And I think it has a lot of potential, especially as we move forward with I mean, the weather is getting more erratic. When it's wetter, it's wetter. When it's drier, it's drier. Michigan overall is getting wetter, but those dry periods are getting drier. So I think it adds resiliency. And yeah, maybe I'll hit my dad up for $500,000 to start this business. Just kidding. Yeah. No, I'm just kidding, Dad.
I'm not an apple grower and never will be.
Yeah.
But let me just ask if my name was Crane and I have a lot of apple orchards
Cranes North.
down in Fenton.
Oh, okay.
Yeah. And you got to go to Cranes in the city for lunch because they
Okay,
have wonderful
okay.
sandwiches. But if I were a large orchard manager, could you look me in the eye and say, hey, if you do this biochar thing, you're going to make more money? That's the bottom line.
That's the hard part. Yeah. Okay. Everything's, you can't say yes or no. Right? So like in wheat fields, they have seen increases of 300% yield increases utilizing biochar. But the prices of wheat don't justify the expense of purchasing biochar to do it. And even the guy who I showed the pictures of, he sells it. He sells a cubic foot. And, for your home garden, it's not going to take, for $100, $200, like a one-time investment, like to make your soil better. Like that, I think that's a no-brainer for a home gardener. Yes. For an apple grower, they are sitting on a massive amount of wood waste. And this is not free. So you got to pile the logs, but then to burn that much, and a lot of times they sit there and they burn it day after day because it's green wood. They're trying to turn around that and utilize that area for production the next year. So they would have to sit that somewhere, but then they are the ones, is that versus that? This is more labor. Right? That's less labor, but it's not labor free. So that is a great question. And I don't totally have the answers, but the one nice thing right now is through your soil conservation district or natural, it has a different name. There's a soil conservation NCRS 336, and it pays growers, was it per ton, like a certain amount, like $300 for application of biochar. It doesn't matter where they buy the biochar. If they go on the market and try and buy that biochar, they're going to be spending way more than they can get reimbursed. But if they make it from their own wood that they're getting rid of, could they come out ahead? I think so. So that's a hedged answer. So I realize, yeah.
Am I hearing that biochar would be considered more organic? And would it stop the having to use herbicides, pesticides, especially Roundup?
No, it could be used for all of them. You're going to benefit whether it's conventional or not. Honestly, you want to introduce nutrients with it, right? And in my own garden, I'm mixing chicken poop and vegetable stuff. You can put conventional fertilizer with it and do the same thing. It's able to lock onto that fertilizer and just hold it better. So it works for conventional agriculture, it works for organic. Yeah. Yes.
Would you use less chemical fertilizer if you use
Yes.
this?
Yeah. It would save in the long run. And also the watering demands, like it cuts that because your crops are able to go longer. So So let's say you were actually, like in a lot of these big grow operations, they monitor soil moisture for turning on their irrigation systems, right? So you're gonna hang on to that soil moisture longer.
Sir, you know, we've had these big fires in Arizona, California and everything. Do you think that some of that we could change into this biochar?
Yeah,
Some of it?
actually, those,
Yeah.
no, you're dead on. These little, and the reason I show this kind is because I think it lends itself to easy portability. But they use this is getting more and more notice out west. In fact, these are designed out west, and they're designed to reduce fuel load near residences that have a lot of vegetation. And it reduces a lot of the particulate matter that just an open burn would have too. And the Forest Service is actually experimenting with like big old, commercial. And that's if I was to do a company, I would try and go with the big ones, right, to kind of meet market demands. And so, yeah. Not yet. Hopefully. Yeah.
This, this kind of research just amazes me to learn that it's going on. And my concern is that with the present political environment, that a lot of this is MSU under stress for continuing this kind of research.
In my department, everybody, like any word of climate change has been deleted. And I have talked to my professor and said, look, I'm 52 years old. Like all of this, I'm doing carbon footprints, I'm doing, net ecosystem production. There's no way to spin this and say it's not climate change. This is climate change research. So I might be the last one standing. And I've told her, like, when I go present, like, if you don't, like, her name's not on this, and just because she doesn't want a black eye, and so that is the reality, but I don't care. Like, we need to deal with it. And, I mean, our kids need us to deal with it. So,
Excuse me, does different species make any difference to this?
in terms of
Apple.
for making biochar,
Yeah.
that's a great question. And do different species impact the biochar? And the answer is yes. The ones that are made from wood, biochars made from wood, tend to behave similarly, but it also depends on the temperature at which it's made. You can make it at lower temperatures, using lab-based processes. You can make it at higher temperatures. This makes it at a higher temperature. But it's kind of made out in the woods too, so it's more variable. But if you're going to buy biochar, I would suggest the ones that have the best properties are made from wood originally, because you can make it out of, I was having a conversation this morning at MSU, they were doing ones made out of switchgrass, and they just, they don't tend to last as long as in the soil. And again, you guys are asking me all good questions, and I have some knowledge on biochar, but it's not my primary research. But they're not as good at hanging on to things from what I've read. So, yeah.
I have several questions. To put things in perspective, what is the dollar value of the apple industry in Michigan?
Oh, God, I should know that. I've included it in a lot of slides, but I don't have it up here.
Okay.
Why is it important, right? Yeah.
Well, there's that.
Yeah.
I'm sure it's very important. One of your early slides, and also one of the last ones, showed kilograms of CO2e. That's an equivalent of some sort?
It is, yeah. And so you had, and I look at the three big ones: carbon dioxide, and then methane and nitrous oxide. Both methane and nitrous oxide are way more potent, but they also have different lifespans up in the atmosphere. So you try and turn it into like that would be worth like 1 kilogram of methane would be worth how much CO2 that was up in the atmosphere for 100 years. So that's what that's based on.
So the CO2e value actually combines all three of those gases.
Yeah.
Okay, I can do the math. All right.
Well, the math is really hard, so I'll get you to work for me.
Okay. To put things in perspective, you showed some, I think, photomicrographs of nematodes. What magnification was that?
That was 20 on the eyepiece and 50 on looking through it. On just so that'd be what? 200 times? Did I do my math right?
I thought it was, you said 20?
20 on the ocular piece,
Oh.
maybe. Might have been 10. No, yeah. And 20, like 10 and 50 would be 500. So
Right.
it'd be 1,000. Yeah.
Okay,
Yeah.
thousandfold, 1,000
Yeah.
times. Okay.
That's off the top of my head. I was looking at it yesterday. So
Now, two questions about
Yes.
measurements. One that you did not do has to do with the equipment that measures the eddy convergence and the CO2. So you explained how the principle
Mhm.
of what is fixed by the plants that is not measured on the return cycle. How is this CO2 measured by the instrument in the field?
Okay. Yeah, it is. Let me just pull it back up. So it it's a highly detailed answer. So so you have a pathway here, right? In what it does is it sends an infrared band. In this infrared band is actually able to measure the signature of CO2 and water molecules. So it also even tells us like how much water is coming up out of this field. You know, what is the exchange rate? And so how that does is that when that you have it sends it, and then up here we have our receptor, right? And let's say there's neither of those gases are present, you're going to get 100% delivery of that infrared molecule. But when it hits a CO2 molecule, it causes it to resonate at a particular frequency, and you lose some of that energy as it gets re-resonated back out in all directions. And so it measures that difference, and that's how it does the direct measurement.
Okay.
This morning I was in the lab and running soil gases. I was doing the soil microbial biomass. And on that, you essentially do the same thing. You take chloroform. I don't know if you know what chloroform is, like pretty nasty chemical, right? And it basically lyses open the bacterial cells, it lyses open the fungi cells, and that releases a plume of carbon that gets decomposed in a couple days. And you measure one jar that got chloroformed versus the exact same soil of one that didn't, and you look at the difference there, but you run it through one of those gas chromatometers.
You measure the headspace.
Right.
Yeah.
So
Yeah.
you sounds like you got some experience maybe with this.
Not with the soil, but with the methods.
Okay.
And final question for now, this is something you may have measured. Thinking of
And
your,
this is measured. Yeah.
yeah, but you,
Yeah.
well, the instrument did that
The
measurement.
instrument did it.
But thinking of your apple orchard alleys, you planted a variety of species and now you've got plants growing. How do you go about measuring, discriminating between the weeds, the other plants, to actually measure the composition of a strip that's several meters long by perhaps a meter
Yeah.
wide? So how
Good
do you go
question.
about doing that?
Yeah, no, good question. So I use the Daubenmeier method. So you establish a transect, and then you have like a little, I mean, it's really simple, just like a little rectangular, like 80, I think it's 80 by 25 centimeters or whatever. You plop it down. And the nice thing, you have to be good with plant identification. That's the difficulty. And grasses are hard. And so you look at it and you measure the soil coverage, like how much is annual ryegrass covering? Is it roughly 5%? Is it roughly 25%? And so you don't have to say like exactly like this is this many, because then by the time you do this quadrant and this quadrant and this quadrant and this quadrant and this quadrant, you have a nice sampling that, you know, if you said 5%, it was really 7%, it's going to come out in the wash because you do enough samplings. So yeah, that's the Daubenmeier method. So this is it. You guys offer tougher questions than I gave this on Monday to my lab group, and I don't know, they were asleep or something. So
Cut you off from doing your last slide. I feel like you were.
no, I mean, it was just the summary. You guys
Okay.
could read it up there. I already said all of those
Yeah,
bits.
great.
Yeah.
Well, I found this very interesting and I'm excited.
Well, thank
about
you for
biochar.
having me.
Oh, it looks like Bill might have a question. We'll have a minute to stay after.
Yeah,
the
yeah. And if you guys have
discussion.
questions for me individually too, so. It's all mom. No, I'm just kidding you. I'm not. Yeah.
You have certain associates who do not want their name on this research because it's related to.
Yeah, politically, yes.
Wow.
Yeah.
That's.
I mean, it's just the reality. They have to. Because if not,
Sad reality.
yeah. Hopefully we'll change.
Well. Don't worry about it. Hold on, you're getting these high density animals.